Sorry for the delay. We had to restart. All right. So we're currently discussing placement on the RC car for our components, especially the battery, which is pretty large. So it's always a trouble trying to figure out where it should go.
We need this distance. We can't bend that too much. Okay, so if we put the battery, we put it like this. So we have all of this stuff.
And not one of those. Or do you do that?
That's why I got rid of that.
So you only have one.
Yeah. That's your judgment.
Alright. Okay, that's good. Is this connected?
Yeah, connected it just to
Oh, no, should not touch all these wires.
nothing else.
This is the. So that's we don't actually need. Remember, this is going to go away. It's this actually takes a lot of space. Get rid of that.
That's probably where we'll put that
Yeah.
So
That's there. All right. Well, let's say you did the battery underneath. So because it does have these dual wells. Yeah. So you put in there. They don't move, so we can sort of Okay. I can dig it.
yeah, and then
These are good protected.
yeah, that's kind of what I
This
was
is the biggest, heaviest, dutiest thing.
Yeah.
All right, but I thought good idea.
All right.
We'll talk and rates 2 times.
What's that? Oh,
And then you got your 2. You got this bus and the battery.
what are you talking about? So I'm thinking we bring that through there. Perfect. And then we connect this. That. Still have. Actually, I want this. I want this all the way as far up as we can go. Basically there. So that this actually comes down.
Really takes it underneath.
Yeah.
So that's actually pretty nice.
We'll just take those down or something.
Tape this and that's your string.
Yeah. So that looks like the ideal solution, I think. So let's mount that there for now. We have infinity Velcro, so I'm not worried about
Yeah, he's not paying the same doctor. The guy got a little overexcited.
So you're happy with my argument to put it under?
I'm happy.
Our argument?
Our argument. No, the tons of Velcro that we have.
Yeah.
If we misplaced it, I'd be impressed. There's not enough space in this room to hide it.
I'm gonna use hooks for mounting and felt for. Let's say scissors.
You really don't want to get the software part, do you?
I want the software part to show something
So do I.
cool. We'll get there. We'll get there. It's alright. I'm gonna do
This is
2.
looking
I'm gonna do 2 just to since it's battery. Yeah, keep it critical.
yeah, really sturdy.
Let's do
One thing I love about a lot of this stuff is I always thought everything needs to be nice, clean, and polished, but then when I got more into it, it's using things like this. You have tape, you have Velcro, you have pieces of styrofoam, you're sticking wires through things, and it's it's prototyping. You're getting stuff done quickly, and I have a lot of experience with that in code, but it's foreign to me in this hardware space. So I think it's good for other people to see that it isn't all this polished product. You look online and you see people building things, and often it's this beautiful thing. They built a whole Iron Man suit, You think, oh my god. But you know what? You don't have to start there. You can start with just these building blocks, just like we're doing. In version 2 or 3 of this, you could actually have a nice 3D printed shell around it and look like a car you might buy at the store. But definitely version 1 does not have to start like that.
It's an interesting topic. I really enjoyed that.
It's pretty
Yeah, you're just off the cuff calling me unorganized.
No. Actually, Lucas was the one who commented on me because I'm building some other projects and I wanted them to be to a certain standard, and we ended up working with some other individuals who helped us out, and what they came back with was essentially what I said, styrofoam. They styrofoam to raise something up. You poke a little hole through it, move the wires through it, and you connect things, and you duct tape pieces down, you glue it down, you solder parts, and sure, you tighten stuff up and it looks pretty clean, but it definitely doesn't look anything like if you bought an RC car at the store, right? And I think it's important to recognize the difference between prototyping and building a finished product and how many iterations are in between what you see, and that's why we want to do the behind the scenes engineering, right? Is it shouldn't be so scary. Just go out and do it, and that's what I love about in the software space. We have this thing called hackathons. I think we do that the same thing in hardware and other industries, but it's essentially going out and quote unquote hacking, meaning to build on something, and you try to build it very quickly. So rather than going and saying, I'm going to spend the next 3 months in building a proof of concept for some crazy idea, what can you do in 1 week? What can you do in a weekend? And you just challenge yourself to do it as quickly as possible. You take shortcuts, you use duct tape here, Velcro there, styrofoam here, and you just get it done and validate the idea and prove you can execute and make it work. So that's something I enjoyed from software. I'm glad to see that you can do that from a hardware perspective. That was not how I pictured it. It was always a big barrier to entry for me. So hopefully other people now feel the same and see that they can do it too. On the hardware side.
That's good. I like that.
Is our chat working?
I don't know. Are you there, Nacho?
Is anyone around? I'm sad that this thing broke.
The whole video.
Yeah, the whole video. Yeah.
Yeah, she's
Yes, excellent. Thank you. Yeah, what do you think about that, Dr. Katie? We were just talking about. Do you find that it's a little bit nerve-wracking to start into hardware? Like it's kind of intimidating, because I found it very intimidating to start into something that was more hardware related. Even this project seemed very far off to me.
If that's the case, we'd be glad I could help bring you into this environment.
Definitely. I can't do it without you. Well, I guess we're gonna find out. We can do it together. Yeah, a bit. Yeah, it's interesting. I think the more you do it, right, the more you realize it's not so mystical. Seemed like it would be a lot harder than it is. Yeah, I agree. Like for me, that's just such a big gap in knowledge you have to know to get started. We go on for software. In our case, we just go for software. You can go online and find 100 different ways to learn how to code Python, JavaScript, and things like this. But with hardware, I find it just seemed scarier. Like there was a lot more moving parts. You're working with electricity. There's physical pieces and different tools you have to pull out. I don't know. It just seemed a little more intimidating for me. That said, I still need to get better at troubleshooting hardware and software at the same time. Yeah, like I feel very confident now after these years of experience for software to debug something. But hardware I'm still finding foreign, and that's what I really enjoy when Lucas and I are debugging something, especially the last stream, is let's pull out your tool belt. And in the same way we have our debugging tools for software, if I'm coding in JavaScript, I can open up let's say Chrome inspector, open up the developer tools, and put breakpoints and these different things that allow me to step through the interactions and really understand how things are working. it's really cool to be able to pull out the multimeter and say, all right, here's kind of electricity that's coursing through the system. What is it doing? Is it doing what I expect? And what assumptions do I have, and how can I test those assumptions? And it's becoming more alike the software debugging process that I'm used to familiar with. And as long as we keep building those tools in our tool belt, when we see a problem, we go, all right, what's the process? How can I break this down? And yeah, I think that was a pretty big barrier to entry for me, and it's been really helpful to have Lucas here to show me more about this. I just realized I'm not showing my face, but
see your face. They just want to hear your voice.
I just want to hear my voice. Yeah, right.
Yeah. Just kidding. They're here for you.
Yeah, here. You want to move the car a little bit down? Yeah, Lucas is very patient. Yeah, he's so great in understanding, and a very good teacher for so many of these topics. Really helps us get into it.
Very sweet. I wish I was better.
We're both going to get better. This is a huge learning for everyone, and I'm really excited. I think it's, like you said, if we can build this, next time we can build a boat. Next time we'll build something bigger, better, cooler, more sensors, more lasers. It's exciting to do something like this because you're growing the foundations, and then you realize the next project is the same. And that was one thing I learned a lot by going to hackathons, is eventually you get to a point where they are all the same and different in their own way, but the barrier to entry, but the actual building blocks you need is the same, and that's the important thing. So you could say, I have a new problem, how do I break down that problem? Well, that's the same skill set you need in all products you want to build. And so I'm hoping this project should bring us out of our comfort zone enough that we'll be able to do this. And if you guys come up with some awesome ideas, we'll say, no problem, we don't know how to do it, let's figure it out, and we won't be intimidated. And we can all build it and learn something together. It's just really cool.
That was a very heartfelt, very sentimental conversation. I really enjoyed that. Enjoyed listening to the way that you're sort of experiencing the learning of hardware and comparing it to the life of software. I don't have a lot of experience in software, so I'm going to be leaning on you very heavily to teach me as well as guide me through our software experiences, especially if we end up having to decode what somebody's already done in languages like Python or like JavaScript or something along those lines. The only language I've really ever had experience in outside of school would be Python. During school, I did some C and C++, but those weren't. I suppose my 6 months of experience in each of those wasn't really as valuable as they should have been. So decoding software is going to be the same thing for me. I'm going to go through the same learning process that you went through with hardware, I would imagine.
Yeah, it's going to be interesting. I found it interesting seeing for a newcomer who's not familiar with software or engineering or any kind of like robust problem solving like this is how they naturally go through a problem, and then try to think about how I would do it. Like we after years of solving problems, especially with software, you have these patterns of things you can do, but how did you develop that? Like, let's bring it back to your intuition for that. And I think that's really difficult for someone who's very good at math to then be a math teacher. You could have someone who's really good at math and not be able to help others also become good at it.
They're so far from being.
They're just so far, right? And they can't be introspective enough. And that's a really big thing, is to actually look back at yourself and say, great, I know how to do it. Why do I know how to do it? Like, what went on in my, again, internal computer, my biological computer, to say this is what I'm going to do and why I'm going to do it, and I have years of experience in history that's promoting me to do this. So I think if we can just build more projects like this, we're going to have that muscle memory, that the way of thinking, that we just see a problem and instantly, boom, breaks it down of how we're going to be able to achieve it.
And hopefully along the way we actually get better at explaining things as well. Because as much as we think we're good at explaining things, we still don't really know where we stand in comparison to the general population. And I think as questions arise and as things come up, we'll understand how to break things down. And we'll actually understand the gaps in our knowledge. Because as Einstein said, if you can't explain something simply, then you don't understand it well enough. And that's probably the case for a lot of these concepts for us.
Yeah.
So we're going to be going through that adventure of trying to break things down to a point where we understand it well enough that we could explain each of the concepts to anybody who came into the stream or anybody that was nearby.
I find that's an interesting statement. It can't explain something simply. You don't understand it well enough. And I think about this a lot at my work because I'm communicating with other people, especially non-technical people. And when you're working with them, I don't think you need to dumb things down, but you need to represent it in a certain way that's digestible by your audience. And if you're unable to do this or explain things simply, I find it's, of course, difficult to convey that information, but also difficult to create confidence in other people. And that's really important when you're working with a team to say, yes, I have this covered. And then you say for the next 5 minutes, here's my explanation. You didn't explain it in a way that they truly understand that you have it covered because you didn't explain it simply. You gave them all the details. And I think that's a lot of engineers, both software, hardware alike, that's something that they miss, right? And prevents them from, in interviews, excelling, working with teammates, excelling, be able to actually communicate these ideas simply, and then instill confidence in your team members. That yes, not only do you know it, but you know it so well, it's simple, and you can articulate it simply. And I think is I don't know if it's a lost art, or at least something that I hope a lot of people improve on, and I see quite often.
An interesting realization I had recently, and this is probably, Glavin said a lost art. I think it's because we've all heard the comment before, standing on the shoulders of giants.
Yeah.
And the fact that I work in power systems, and the fact that I can do things that Nikola Tesla spent his entire life trying to figure out how to do, really just shows you, like Nikola Tesla's explanation of something would be a lot simpler than my explanation of how something works. But I can do the things that Nikola Tesla could do, that took his entire life to accomplish. I do those things on a daily basis, which is pretty astounding. But it means that I'm a doer, but it doesn't mean that I understand things to a fundamental level, the same way that Nikola Tesla would have had an understanding. So I'm thinking, I'll show you what I'm thinking. So I'm thinking this there, and this there, and then power to the Raspberry Pi.
Nice. Oh, that's great.
Yeah.
Aren't you glad I said make it the best?
Put the battery in the middle. Yeah, that's my favorite part when you said that.
This is great.
This is very slow. I'm glad you're happy. I want you to be happy.
It's definitely not just fine for now. It's one of those long-term things.
Fine for tomorrow. Fine for tomorrow. I'm pretty happy with that. This is turning out. This is good.
All right. Now, do we want to prop this guy up so I can start coding?
You still can. You still have to. By the time you have a script, I'll have a wire.
All right.
I'll motor wire it.
All right. Let's try it. Let's trust him. Let's make it happen.
Don't trust. No promises. Just
he promised it's going to be great, and I got to take his word for it.
What do you think, Nacho Kitty, about the comment standing on the shoulders of giants, as well as the comment of if you can't explain something simply, you don't understand it well enough. Do you agree with those, or have you experienced the opposite, or what's your kind of mindset in those topics? They're interesting. They're a little bit more philosophical than technical.
I think that's very true. Like I think about the tools. Oopsies! I think I might be showing the wrong screen. The tools that we have now. You're not like you said, Nikola Tesla. Like he's gonna have to understand something so well, thoroughly, and we can simply say, "Oh yeah, it's just on the internet. Something else handles that thing. I don't need to know about the details." And you can still be very functional, right? Yeah, like assembly. Like in software, I don't need to know how the transistors work at a very low level, or the assembly code, and I keep moving up, and I have my operating system and the kernel, and there's all these different layers that eventually comes up to my user space where I'm building my application, and even that, I have some sandbox, and there's JavaScript inside of this. There's hundreds of layers in between my code and everyone else's work. And that's a big thing, especially with open source. You know, most of the web is powered by open source, just code that's written by other people. So how do you be confident in, one, that it works, or two, how it works? And the answer is often we don't know. One of the tests that I use when I'm working with others to see how experienced they are is if there's a problem in some library, some other thing that you depend on, can you debug that thing? Can you poke at it and reason if how it works? So let's say you're using some other library, to build your web application, for example. Can you open its code up and break it down and try to solve a bug in some other level, in code you've never written, in code that's maintained by someone else, probably hundreds of people, or is that too fearful? And I think that's a barrier to entry as well, even within software, is just other people's code where you don't really have that much support. And that was something when I was starting my own startup company years ago. There was no one else. So if there was a bug and I'm leveraging open source like everyone else is, I simply had to go and figure it out. And I remember my business partner at the time we were up to 5 a.m. just sitting there coding away, diving through open source code, and we figured it out. And then after that, we went across the street and got a big pizza at 5 a.m. just to celebrate. And and that was great. But I don't think a lot of people are compelled to do those kind of things, right? Because they, like you said, live on the shoulders of giants. It just works. It's not broken. Don't fix it. And they're not going to be challenged to dive into these uncertain areas, and they will only ever scratch the surface. And that's even if you have your 20, 30, 40 years experience. That's why I find age is not a very good indicator of experience and skill level, because it's about those experiences you had in that time. And you could have someone that just had some crazy projects they're working on and ramp up in months more than some people ramped up in years. So I think it's interesting. There's some people in the chat. Let's see what there's saying.
I didn't get a chance to read them.
Oh, it's off now? Okay, I'll pull it up 1 second.
Yeah, Nacho Kitty says, I agree with the shoulder of giants thing. I mean, without the people that came before us, everything I do and know how to do are irrelevant. Like, my work skills are built off the work of many others before me. Even my cooking skills are based on the inventions of others completely.
Cooking is a big one. And that's something that I talk with my partner a lot about when we're trying to learn new things, like whether it's kitchen design or cooking. Like my way of doing anything is very similar to the way I like to do software, which is like understand it very deeply and fully. So when you find someone else who just says do this thing and there's no why attached, it upsets me quite a bit because I want to know the why. I want to understand the behind the scenes, and most people don't care about that. So I'm often saying, hey, we need to dig a little deeper and learn something more about it. Why does this cooking approach work? Why does it taste better? Why is that quicker to make whatever you're trying to bake or something like this? And not just, hey, it works, magic, great. Because the why helps you realize that this technique over here and this technique over here have common pieces. And you actually recognize patterns, and you start to be able to do transfer learning. And you're able to do creative things as well, because you see the building blocks. You don't just see one big block. You see all the little blocks that make it up, and you go, oh, those are the same blocks in between. I can make my own big block by combining all these different approaches. And that, to me, is how you excel and how you're going to create something new, something that no one else has thought about, which is what I like to do on a daily basis, is create new things. So, I think that's a good point, especially with cooking, like in all these different fields. Now, what are your thoughts, Lucas? I'm taxing you as you're working away. Say something funny.
Horseshoes.
Horseshoes.
I don't know. I choked. I'm choking.
It's all right. All right, let me.
Horseshoes. I don't know it. I definitely. Okay, let's take a step back. As far as Glavin's perspective on learning and my perspective on learning are actually a little bit different. And I noticed that last time we...
Yeah, we did. Yeah, that was interesting.
Yeah, so we learned very quickly. Now, it might be because we were playing in the software realm, and I'm not very familiar with the software world, and I am familiar with doing pretty complicated things in software without understanding them whatsoever, because I at the very least understand how to find what I'm looking for to make something work. Whereas Glavin is looking for, how does this thing work? completely. Like Glevin's looking for the understanding in software that I'm looking for in the understanding in hardware. So when we were working together, Glavin was questioning a lot of the steps along the way, which is completely acceptable, just a different way than I approach. Basically, my approach is make a thing work and prove that it works, and then dive in. And my reasoning is simply what's the point in me trying to learn something if my example isn't proper. But that comes down to the fact that I don't know how to tell if a piece of software that I'm working with is 100% proper, 90% proper, or less. So I got to cut my losses at some point.
Yeah, and I think that comes with comfort as well. So a lot of people talk about in software, they talk about kind of the first time you write the code, and you hit compile, you hit run, and the likelihood of it working the first time. And they say that's very rare. The way I like to conduct it is I should be able to look, like, all the information I need is technically in front of me. And if I totally understand it, like you said, if you explain something simply, you know well enough, essentially, I should be able to reason, given just the stuff that's in front of me, how it's going to interact, the potential problems, what's going to work, what's not going to work, the things I should do to prove my assumptions. So when I don't know something like that's a pretty significant gap. My expectation as the standard is it should work first time, and it's a bad thing if it doesn't. Not the standard is I'm not going to have it working the first time and I keep fixing it. Because my goal is to have a good enough understanding of what I'm writing that the first time it works, and that demonstrates that I know every aspect about it to completion. And it also means if I want to add a feature, I'm in a good position to add something on top, and I'm not playing catch up, or I'm not in a position where I don't understand something fully, and I do this thing when I should have done this, or I do this and it causes such and such problem. And a lot of people have those gaps, so they'll do this and not know why that's a bad thing. And again, it's a very different approach, and you have to have the luxury of time and the luxury of building a lot of things. So you made 100 mistakes. By the time you built the 100th project, that project, like I said, all the building blocks that come together, it ends up just being the same project. It's just pulling the building blocks. You've already done it before, just not in this slightly different way. So the chances of you doing it properly should be 99%. It should be running, executing, compiling the first time. And that's how I like to be. So, but it is different. It's different from a lot of people.
And I think maybe it comes down to my background is slightly software with a lot of hardware, whereas your background is slightly hardware with a lot of software. Maybe there's a difference there, because like hardware is this interesting one where you talk about if you understand everything in software. In your code, everything that's in front of you, theoretically it'll work first try. Hardware isn't like that. Hardware, there are external forces at play when it comes to hardware.
I love it when you talked about NASA earlier. You have to put in error correction in computers and redundancies because solar rays can bit flip. And just who would think of
electromagnetics?
Like just crazy, right? So imagine you wrote a program. It's beautiful, works great in planet Earth. You put it up in space, it just doesn't work at all, right? And that's the kind of stuff you have to think about and debug. So yeah, that's why to me hardware is kind of sketchy, because there's so much. Like in software, we can write the physics engine. We write all the rules. We test all of the hardware to a reasonable degree, like the processing units. We test the RAM, we test all the operating systems. Like all these layers are very big and complicated, but they're all tested. And then we build something in hardware and send it to space, and we can't sufficiently test up there, and boom, like you said, external factors.
Yeah, well, I mean, last time we had an external factor that was something that we could have understood. The grounding issue was something that we could have understood. We just hadn't experienced it before. We never experienced the grounding issue. I've experienced it in other ways, but it's not something that I think about very often. And last time it really kind of bit us for a good 20-minute troubleshooting experience. And I think we both came out learning something pretty important for our future electronics business that we need to calm down between systems. But nonetheless, yeah, in the hardware world, I do expect things to work first try, but I don't mind when they don't.
Yeah, I don't know if that's
Like,
yeah.
yeah, it doesn't beat me. It doesn't hurt.
When people like I'm to an extreme, probably an unhealthy extreme, like to the point where someone's gonna say, "Ooh, this tastes good," and I'm thinking, okay, but why? Like why is your tongue liking it? Why are you as an individual like it? Like if you look at this room, maybe not this room, but other rooms, what makes the colors aesthetically appealing? What's going on in your brain? Like, and I'm just thinking, like there is a why. And some psychologist with a PhD actually knows the answer. There's someone who's done the research, and every time I think there's a science behind this art, every time I'm able to find that person online. And I don't know. I don't know if that's even related to what you're saying anymore. I lost where I'm going on, but I think there's just a lot more to it. And I think if someone studied their whole life on something, they should be able to understand it really well and get things right first try, and just do it really well. But there are definitely a lot of external factors. I don't know where I was going with this.
I think you kind of brought it back at the end there.
Yeah, just a little bit.
You kind of went out into the
way out there.
into the left field. So
I'm having some troubles with this Raspberry Pi, so I'm random now. It won't connect over SSH. It is no longer connecting over SSH.
Oh, did I get it maybe?
I just unplugged and plugged back in, so I'm hoping that's gonna help.
There's no data stream flowing.
Oh.
I'm not lighting up.
How about now? Is the light flickering?
No.
Oh, I think it's still connected to the VPN.
Yeah, I mean, once in a while I do get frustrated, but like, the problem with hardware is every once in a while you do run into a piece of, like our troubleshooting of the Raspberry Pi, just to find out that we're 90% confident that Raspberry Pi was toast. But we had to prove it to ourselves, because it takes a lot to send it back to the manufacturer. So we weren't really willing to make that call unless we were 100% sure that it was faulty.
And that's still concerned. Like that bugs me that I can't confirm 100%. Like I know there's something wrong with it. The fact that I don't really know yet what broke or why it worked temporarily or anything like this.
Yeah, the biggest thing for me that made me say, okay, this definitely has to be broken, is the fact that the internet talked about scenarios where several users using the Raspberry Pi 3A experienced a one-time successful boot and then never again experiencing a successful boot.
Oh, interesting.
So the fact that somebody else experienced that exact symptom kind of got me to a point where I agreed.
Yeah, that makes sense. Oh wait, sorry, there's some chats going on here.
In terms of flavors, she's talking about when you were talking about food and how to enjoy it versus not enjoying it.
Consider the hardware adds problem. Hardware adds a problem. Genetic kind of yeah. So that there's a lot to catch up on. Yeah, exactly. So like, what's kind of the genetics of it? I think for me, colors is something I'm not particularly good at, like artsy things, judging the colors of things. But I know there's a science behind it, and I know that not everyone's the same. But I know there's data about it. There's colors that give you certain moods. There's colors that work together. There's shapes and lines and different patterns. And my partner and I did a lot of research, and we found books that exactly detailed exactly what I would expect. But that's one book out of 100 books that talk about do this thing and not here's the science why. And I think it gives you insufficient understanding of the background such that you can create new. Like my goal is to create new things. Let's build this RC car. To be able to execute something new, completely fresh, it is to understand something so well that you can you can create something that never existed before by kind of entangling these different ideas and recognizing that up until here this idea is good and this little part can be changed. But when I someone, like, I keep thinking about interior decorating because that's something we're doing for our house, is like there's a science to it, but a lot of people say, oh, here's the common color palette that everyone uses. Okay, great. So that's tried and true and tested. But if I said create a new one, you would be unable to do so productively because you don't know why that's a good pattern. And they've done research on a lot of these things and finally found some books on it. And what excites me more is the future of machine learning in this application, because machines, we could teach them in terms of rules, or if we don't know why, we could just give them a data set. And they'd actually done this. There was a study I was reading, a white paper yesterday. It was about the automation of layouts in rooms, furniture layouts as well, and the color harmony. And they had a data set, I think, of 100,000 or more color palettes and a ranking. So the ranking was done by humans. So other humans have actually said, this is a great color palette, or this is a bad color palette for these 5 colors or something. And they were able to give this to some machine learning algorithm, and it learned how to look at these colors and say what's a good color. And there's a human that would have done research, and they know exactly why, and they could actually they could explain it simply. Or you can have this massive machine learning model. It can't explain it simply, but functionally, it's able to evaluate all the 100,000 we tested. And if I give it a new one that has never seen before, it will evaluate it as well. And it will be able to create and be creative and reflect and evaluate its own. And I think creativity is the biggest asset we have as humans. So if a machine right now, given a ton of data, can learn to be creative, it can't explain it simply because it's not smart, it's just statistical learning. But if a machine can do it, and we're not thinking critically about the why, such that we can explain it simply, so we can explain it in the same way a machine can, but we can explain it simply, that gives us an advantage. But if we don't have that advantage, machines are going to beat us out. And I'm very concerned for the future of people that are not thinking really deep and critically about the why, because they're not able to create. And creating things is our biggest asset. That's the biggest driver for innovation. So I don't know. So it concerns me. It keeps me up at night. But I don't know your thoughts on that. That's a whole other tangent.
Well, the keeps me up at night thing. Well, I don't think there's anything that actually keeps you up at night. I don't think you go to bed.
This is yeah, no word of a lie there.
That was, I mean, I know that wasn't the question you asked. And it's a very interesting concept. I agree with the idea. I agree with the idea that we're human. One of the biggest differentiators currently for humans and computers is the fact that humans can think in abstract ways. So we have the ability to say that looks right. And not really go any further than that. Still understand that, that looks good to me, and I think that'll look good to a lot of people. Computer doesn't really know that yet, but like Lavin said, they're starting. I guess machine learning researchers, probably the best guess. Machine learning researchers are successfully trying to successfully bridging that gap into creativity with software, which is pretty astounding, and it really just shows you that that computers at some point are going to have the capability of giving us recommendations in areas that we would have never expected them to be able to give us recommendations, which is huge.
Nacho Kitty's saying, by the way, they can learn. By the way, they can learn that. If we also don't know the why, computers will just use our input to learn an opinion. Yeah, exactly. That's what I was saying earlier. With given a sufficiently large data set, they'll learn it. They need more data than us, but they will absolutely learn it as a machine and give themselves a competitive advantage. And they only improve from there. Like we as humans, we have to very slowly communicate knowledge transfer. A machine is just going to get really good and then get better. It just only gets better from there. There's something else I want to comment on. I forget now.
I was what she was.
Probably both of you. What was the last thing we said? We need to rewind. Is that what you meant by they can kind of learn that? Oh yeah, it was about what Dr. Kitty was saying. They can learn that in the why. So actually, there's a big gap right now when you have, let's say, a neural network, for example. If you have a sufficiently big neural net, it's very confusing. If you're doing a neural network is modeled off biology. I won't get too much into it. Picture a black box. Its design is given any input, you can have this black box that will learn to do some magic and give you some expected output. So it's the universal approximator or solver or some black box that will accomplish a task. And let's say you wanted to look at an image and see if there's a hot dog in it. So it's hot dog or not hot dog. And you could write this neural network, for example, or there's a ton of other machine learning approaches, and they would process that image and tell you hot dog or not hot dog. But it's not really helpful because you look at the model and say, okay, why? And they looked at it, and they've actually determined if you have multiple layers in this model, the first layer is doing simple things like edge detection. So I know a hot dog is shaped like this, here are all the edges. And then I take the edges, and the next layer is doing another kind of processing, and the next one's another kind of processing. So they can get a couple layers up where they actually know the what of the model's actually doing, but they don't fully understand it because again, it's just tons of numbers, it's very abstract, and it's just going to learn some crazy magic, right? It's a black box. But there are other approaches they have, which is kind of having the supervisor, and it will give it different inputs and then tweak those inputs in ways to explore how this black box, this machine, understands this input. And it will try to gauge the relationship between the input and the output. And I can't remember what the project was called, but the end result is if you give it a model that, let's say, has learned hot dog or not hot dog, and then put this special supervisor there, it will give it different images, and the end result, it will say, oh, I know what this black box is doing, and it will tell you, oh, it's actually, this is what it's looking at. It's looking at this part in the picture here. It's looking at this part of here. It's looking at the edge and shapes. So it will actually learn what the other model had learned and then help you understand what that had learned. And they use this a lot for machine learning, obviously. It's a big one. Okay, why do you think the hot dog is there? These are the reasons that this model thinks the hot dog is there. And it knows this because it changes the hot dog image until it breaks it or it makes it work or vice versa. And because of this experimentation, it's able to learn it. And they also use it for text. Because if you look at a big sentence, what parts of the sentence are important? So this supervisor model can change the sentence in different ways and say, does it still interpret it correctly? Or how does it interpret it when I add different words or change different words? And because of this, it can learn what words in the sentence are important. So you can give it this new sentence, you give it the model that's been learned to interpret the sentence, and you give it the supervisor, and the supervisor says, this model looks at these words and comes with this conclusion, and here's why. So even that, we have a machine that's learned how to interpret another machine for humans. I mean, at the end of the day, they will solve all problems, and just laugh at us a little bit.
At the end of the day, they will solve all problems.
Let's talk about what do you think the hardest problems to solve as a computer will be? What's the last problem that a computer will solve?
I'll do one better. What do you think the last profession will be?
I guess it's the same question.
All right. I think comedian.
Why comedian?
Comedian's great. So
There's so much data.
Oh, yeah, but enough. Still, no. We talked about this earlier with context, right? It's all about jokes are not only natural language processing, but there's a lot of context. There's timing things, eliminating the need for people. Yeah, I think comedians are going to be one of the last professions because if let's say I wanted to replace doctors, there's a ton of data.
Yeah,
it's very scientific.
We're already getting where doctors are using robots.
We're already doing it. IBM Watson is trying. So like they have radiologists. Like anything that's image processing, there's a lot of image processing in medicine. Boom, gone. Not sure today. I think we'll probably talk a lot about that. And then there's other fields too that keep moving up. IBM Watson, it was the robot that beat Jeopardy, right? And that's taking all of Wikipedia, understanding it
maybe not perfectly well, but sufficiently well to answer questions and beat Jeopardy with some of the best people in the world at Jeopardy. And then they said, let's apply it, same techniques, but on a body of text that's medicine related. And no problem. It's just text. It's going to learn how to process it, and it eventually will get good enough to be just like a doctor. It's very structured still. But when you keep going through all these layers, that's natural language processing, parsing the text, understanding intent and meaning. But jokes, I think, are very difficult. There's a lot of layers. There's just looking at the content as a textual form. There's looking at the body language, the delivery. You can hear a lot of people telling jokes, and two people can tell it differently, and the delivery is totally different. Last to replace politician. I actually think politician will be sooner, because I think the field of having a politician, I would love for it to go away. But I don't think it will. I think it's too scary for us. But I talked to Lucas about this, the future of everything being run by machines. And there's a couple of thought experiments about that, but we'll get into that in a moment. But yeah, I think there's so many layers, so much data, so much context, that given all of the internet, if you could have a machine that parsed all the internet, they could figure out, to replace all the jobs, but the hardest one they'll do is making jokes. Because I think it's just an extra level of context, and us as a human finds it easy, and I think that's hilarious.
I don't think we find it easy. People are very good at being comedians.
I think but I mean, very good at recognizing a joke. Like, even recognizing a joke is difficult. There's been people trying to do that, but that's the thing with robots. Machines get really good at improving themselves when they can in fact recognize themselves when they're correct. So the reason why you can make a hot dog not hot dog is you can use something called supervised learning. I know the answer. I'm watching you and say, here's your input.
Laughter input when you're...
And you could do that. But they might, yeah, and I think that's the thing. You have to have the right data set. But if you have the laughter input, that's a good feedback. So your model there would be, input is the joke. It would be the text content, maybe a video feed with the voice delivery, the body language being interpreted, the tonality, like all the different characteristics in the delivery. And hopefully the model has enough context to interpret the joke and understand. Who knows? For all we know, 1 week prior, there was a new thing in the news that you had to know to get the joke and think it's funny.
That's a good point,
right?
actually.
Like, it's so current. And we'll just go out and watch a comedy skit for an hour and laugh our face off. And I think that's going to be one of the hardest things for a machine to ever learn. And that's kind of nice, though, because I do think creativity is the hardest part. Because even machines that emulate creativity are going to struggle with it. Here, one sec. Not sure Kitty's talking quite a bit. Last to release politician, they seem to have no rhyme or reason, and it might be hard for a computer to understand. Yeah, with all the double talking.
It's hard for people to understand too, so it's not really a loss.
It's a feature, not a bug for politicians, though, to confuse people and audiences. Yeah.
You've seen the Trudeau water bottle?
I don't think I have.
The water bottle conversation?
Oh no.
Oh, my Lancer. He was trying. Somebody asked how he was going to try and reduce plastic waste, and he's like, "Yeah, we've converted to drinking water to drinking water out of water." Couldn't say water bottle. Yeah, so everything's mounted on the car. I think it's actually mounted pretty well. If you want to take a look.
Well, that's so painful, the water bottle thing. Yeah. Sometimes a joke depends on audience, history, context. Yeah. I think it's just my point being is it's very loaded. And it's very creative. I think what's funny is the jobs that are really difficult right now is I want to go and I want to just do something creative, and I don't really know who wants it. I just want to spend some time. I went to Ottawa with family last year, or maybe probably 2 years ago now, and there's this big beautiful garden, and it was made by volunteers, and I think we paid an admission, but that's probably just for watering the plants, right? And you just think so it's not enough money that they could get paid to build this thing, but it's incredible and everyone wants to see it. So imagine a future where you don't have to do a bunch of things because robots replace us.
What you're talking about is making the government obsolete, and that's it. Things that people don't want to pay for.
Government.
That's government.
Yeah.
Government, we pay for it with taxes.
They're going to smite us right now. Yeah.
Government.
But yeah. Well, so I mentioned earlier, there's a thought experiment. Is in the future, if you had a machine that learned how people behave and it knew all the moves you'd make and all the resources you have, why go to war when you could just go and say, simulate a war between two countries, and the machine says, I'm sorry, your side's going to lose. And you don't go to fight.
Go
You
play.
just accept it.
You're literally describing one of my favorite video games ever, which is
Madden.
no. Yeah, Madden. Honestly, no. It was just Risk, but it was
Yeah.
an online version of Risk, and you skip all the rolling.
Exactly. Just risk at a ridiculous scale, right? But the question being is, if the machine could tell you this, would you trust it and not go to war? Or would you say, what do you mean I'm going to lose? I'm going to take you on anyway.
Yeah, that's the thing. America would be like, oh, our simulation said we're gonna win. That means we're definitely gonna go.
Yeah, it just hardens your resolve.
Yeah.
Yeah, so at the end of the day, we still go to war. And it's like, why?
And realistically, the government would be like, oh, our simulation said we're gonna win. Wasn't true,
Yeah.
but they said so that you get tougher and then you do win.
Yeah.
But take a look.
Yeah, that's definitely one of those things where you don't want to have a lot of data points.
I could shrink these, but since we saw them, I kind of want to do
I prefer to
this.
keep them long for now until
Very short, but everything else is
This is looking great.
This is all tight in here.
I like the colors in reverse though. Could you? This is awesome, man. This is awesome.
Not touching it.
All right, so let's see if this thing even works still.
Yes. So what I need you to do, Glavin, is go onto the interwebs and find which pins on the Raspberry Pi are PWM pins. Those are the ones we're going to be
12.
using. No, there's 4 of them that I need.
12. Is it connected to interwebs?
Yeah, but you would have lost connection. I unplugged it for a second.
For a hot second? It's plugged back in. Now?
It is plugged in. Yeah.
It seems to disagree. How long ago did you plug back in?
A minute. 2 minutes, 5 minutes, 10 minutes.
Looks so clean, almost symmetrical. Almost. Nacho Kitty says you should redo it. I think the implied quote was "do better" or "get good."
What? There's no get good there.
No, I'm just I'm implying from context, inferring from context. It's almost symmetrical, but not entirely.
It's as close to symmetrical as I can get.
Oh, she's not disagreeing. Yeah.
Okay, the Raspberry Pi should be available. But you should Google, while you're waiting for that to boot up, you should Google
Googling.
Raspberry Pi pinout and find me the PWM pins.
I haven't been typing too much. It's slowing me down. I love it. Keep the comments coming. I appreciate it. Is there anyone else still watching? Love to hear from other people as well. Give Nacho Kitty's hand a break from typing.
What'd you come up with?
All right, one second. I want to show that screen as well.
Actually, wait. Uh-oh.
What you said?
I'm missing a piece. Oh no. That's bad.
What?
I'm missing a jumper.
The little guy?
That's bad. The jumper that goes across here. I don't even know what it does, really.
Well, that's not good. Do you know, did we have it earlier? Oh, what about that?
How the hell did you see that? Yep, that's it.
Woo!
Heart attack averted. Crisis averted.
I suppose we could just solder them together.
Yeah, but I don't know if you have to take them off for any reason.
Only if we, what, that was it an enable pin or something? Okay. We want pins. This is Raspberry Pi 3A Plus board, 40 pins.
This is a 2B actually, but it's the same pin.
Oh, this is the 2B. Yeah. It's the same pinout though?
Yeah.
Okay. You want PWM.
Wait, we need 8 PWMs, don't we? 2 for each motor. 1 for forward, 1 for reverse. Holy shit. I don't think we have 8 PWM pins, do we?
What?
PWM 1, PWM. I'm looking at your screen.
Oh, okay.
Go back to the pinout. I think there's 4.
I thought there was 4. I thought we checked earlier. At least I hope so. I see,
I see 1, 2.
like, I'm seeing GPIO 26, 23, 6, 1.
Interesting. I'm just gonna leave it for a minute. Let's see.
A little bit awkward if this doesn't work.
It'll work. Just have to.
Need some kind of elevator music or something. So is this diagram sufficient to see? Like I see 4, but I see PWM 0 twice. So what does that mean?
I'm not sure yet.
At 1, 23, 24, and 26. What is this? A 2?
But you said we can do some things to trick it, because you said that 2 of the wheels do the same thing and 2
They
of
do.
the wheels do the inverse, right?
They do. That's correct.
So we can just use a breadboard and inverse them.
2 of them. The pairs do the same thing, but the pairs have different calculation. Like we need 2. We need 2.
Pairs have different.
So like these 2 will be the same. These 2 will be the same. But it's not like these are the negative of this.
No, that's fine.
Yeah.
But these two do the exact same thing.
Yeah.
Always.
Yeah, that's right.
Because then I can just control. Because then we control both those motors with the same pin.
Perfect. Yeah.
So yeah, there we go. Done. You know what I mean? Because I can.
I do. Yeah, that makes sense to me. Yeah, I wasn't sure. I didn't suggest it because I wasn't sure if we need like that pin to have a single direct line, like for voltage reasons or something.
Single direct line. Nope.
Okay.
No need.
So as long as the value is what we want, that's all. Cool. All right, even better.
Yeah. So we only need 4. Perfect. So I think we're good.
Like only 4.
Just well, we need 2 for each wheel. Right. So each wheel is controlled by 2 PWM
And you
pins.
were looking for 8.
I was looking for 8. Now we need 4.
And we have 4. Oh. Okay. That's why I was confused because I was like looking for 4. I found 4.
2 for each wheel.
Okay.
4. Yeah.
All right. It's probably.
How am I gonna jumper them now?
You gotta, so plug the female into that and then splice it out to 2 sources.
Yeah, something like that.
Can we shove 2 males into that one female?
No. I mean that would be the answer, but no, not quite. I'm not too worried. Like I'm not looking for a way to do it. I'm looking for the best way. So I'm just thinking.
I like that kind of thinking.
Yeah, I don't wanna just hack something because I could literally just strip back a wire and do it, or put a breadboard on the car. But I don't want a breadboard on the car. So what we could do.
Breadboard in the car. I see what you mean. Okay, yeah, let's not do that. Duct tape?
We could use this.
Oh, we do another one. So are these separate? Like if I connect to this, it does not communicate with this one?
That's correct.
So we could have these. How do we need this? So these 2 would be.
Those are the same. Yeah. So what I would think to do.
So that's like ground and that's power.
Like, do we still need ground and power? Right?
So that's this is just nothing now. Nothing. So let's bring. So what we could do. Is
Oh, I see. It's direction and magnitude. That's what we have too.
No. It's 1-1 or 1-0 or 0-1. Or sorry, it's 1-0, 0-1 or 0-0. 0-0 being off, 1-0 being forward, 0-1 being backward, and then less than 1 is just lower throttle.
Isn't that what I said? There's a pin for direction and a pin for speed.
No, because both pins are for direction and speed.
Why would they do that?
That's how you have to do it with 2 pins. It's just how you have to do it. So imagine, so if it's 1-0,
Okay.
if it's 1-0, it goes forward at full power. If it's 0.50, it goes forward at half power. If it's 0.5, it goes backward at half power.
0.
So the bit placement matters. So like if it's 1-0, it's forward. If it's 0,
Can we write this down for the audience and also me?
pretty simple.
I think it's pretty simple. I just like it written down, considering it's not like.
I know.
What to me it was obvious to be direction and speed pin.
Yeah.
The fact that it's not irks me, but I think it makes sense.
Where did my pencil go?
I ate it. Here you go.
Okay.
Oh, is that thing turned off?
Yes.
I think you should like it.
Okay, where did our stream go? I lost our stream. Oh, 'cause that was good.
I need to take a quick break to get a drink.
Sure.
So
Do you want me to wait for the explanation or just?
if you could write some stuff down, I'll be back in a quick minute.
Okay, so basically, each motor is controlled by 2 pins. These 2 pins are either a 0 or a 1 or a 0 and a 0 or a 1. So if this guy is a 1 and this guy is a 0, then the motor will drive forward. If they reverse 0, 1, the motor will drive in backward. If this is 0.5 and 0, it'll be forward at half speed. And if this is 0 and 0.5, then it'll be backward at half speed. Hopefully that makes reasonable sense. I'm gonna try and write it out a little bit better than that. That wasn't the most clear way I could have said it. So basically, we have a motor, and we have a binary input. We have 2 binary inputs. If this binary input is a 0 and this binary input is a 0, the motor does not move. No move. If this binary input is a 1 and this binary input is a 0, motor goes forward. If this binary input is a 0, this one's a 1, it'll go in reverse. If this one is 0.5, or which is equivalent of 2.5 volts because we have a 5 volt source, and this is 0, it will go forward but at half speed. And if this one is a 0 and this one's 0.5, it will go in reverse at half speed. And that 0.5 could change to any number between 0 and 1, and it'll be that percentage of the full speed of the motor. So if it was 0.6 and 0, it would be forward at 0.6 speed. That's my understanding.
So weird. Okay, that's fine. Alright.
Okay. So, what we could do, I don't know where we're going to
Wait, so is that. So the opposite side is always 0? So that makes. So this is like the speed, the magnitude in the opposite direction, magnitude in the forward direction, and then make them mutually exclusive. That's all I had to say.
I don't know if that was more clear than what I said. I mean, you can think whatever you want.
Is that a PWM thing or the motor thing? That's the motor there.
That's the PWM thing.
Right?
That's what you're pushing.
So we don't.
That's fine.
Do I have to abstract that? Like, is that handled by me just saying PWM do the thing?
Yeah.
Okay.
So if you go into Python, into that Python motor pwm.py.
Is this connected?
You asked me that. But it's listening. No?
I'm very sad right now.
Is it not connected?
Did you try another one? Is it working? Does it show up anything on yours?
It's really.
It is not here. Yeah, the lights are on. Where's this? Let's see that. This new cable we just got is working.
No. I got nothing.
I got nothing for that either. That's super upsetting. That's not cool.
Oh, actually, this is my fault. I accidentally hit the SD card and knocked it out.
Oh, so it was starting and not. See, that's frustrating because it looks like it's working.
Yeah.
What a piece of.
I'm just gonna plug it in again.
Yes, please. Thank you. That's no worries. I'm glad it's that. I was just concerned we'd find something else. I was like, what is our luck? I don't understand. At that point, it's not luck.
At that point, we did something wrong.
Yeah.
You do too many things. If you're unlucky that many times, you're not unlucky.
Yeah, there's a lesson to be learned here, some people.
So I'm gonna mount this. This is gonna make it asymmetrical going slightly.
That's right. Nacho Kitty will be very disappointed. I will accept you.
I accept you.
Now that you see all the mess that's on here, you're like, okay, symmetry is. I think I'm put it like here so that we can jump over that and then go to these.
That logically makes sense.
Okay.
I think it's a good reason to tell the symmetry. What is this? This HDMI. What is this?
It's another power plug, so you can put power into there if you want instead of here.
Okay, cool. I like it.
Yeah, it's actually gonna look a lot better with the Pi A3 because it's smaller.
Yeah, low wireless is not big things. What LOL? What in reference to what, Nacho Kitty?
What?
What? Oh my god, it's online. Thank goodness. It's only took 30 minutes. I love how he's like, yeah man, just go write the code. It will be fine when I'm done. And then unplugs the SD card so I can't write the code and then takes a half an hour to finish.
Look at that, it's done. Look at that.
Look at that, it's done.
I'm done and
You were right. You did beat me to it. God. This guy. Alrighty, let's see. Can I log in now? Oof. Yeah, Nacho Kitty.
I'm done and you're not.
It's just this guy.
Damn, this is actually looking pretty good. This is the best
It
mountain
is.
job I've ever done
So far.
so far.
Just
That's
wait
pretty
till you
damn
make that boat.
Speaking
Make
of
him
prototyping,
sweat.
speaking of prototyping though, this is pretty good prototyping.
Yeah. I don't think this is the best example of it doesn't have to be polished. And then he just makes it beautiful the first time.
I put in a lot more effort into this than I normally would.
That I have observed. I mean, I love you. This is great. You're doing great. Okay, so that was the motor PWM file.
Yeah, so that's the example that we used. Remember the light that was glowing, and we haven't tried PWM on these motors at all yet. So I don't know if what I said is even true. So let's test that in PWM script on one of these motors before we go any further. Just on one of them. So which pins does that PWM script use?
12 currently. Oh, that's for an LED.
12 in ground. That's fine. It's the exact same thing. So I'll just use 12 in ground, and then we'll add them all in.
So what we're expecting to see is it ramp up and then ramp down.
That's correct.
All right, I'm excited. You excited?
I'm excited. Let's see.
Can everyone read this? I highly doubt it.
Can you find me where 12 is?
I can.
It's pretty small, especially if they're not.
Yeah, I'll make it bigger.
Especially if they're not going full screen. I can read it on mine, but it's pretty small.
Yeah. Do you want 12? 12 is which number? That's speed? So it's GPIO 1. It is
Like where, with respect to the USB port.
like right beside it, probably. No, that's down there.
So do you think? I just don't know if one starts down here or one starts on the other side.
I actually have no idea. It says on the thing.
Yeah. New one does.
Get a different one. Just pick. If you go back to the Google Images, you'll see one that actually shows the pie. Kind of tells you which one.
Okay, so we
one is
want
inside left away from the. Okay, so this is one inside left. Inside left.
power. Yeah.
I'm looking for the first one. So one, if I'm looking up there, that inside is one right there. So I'm looking for 12. 1,
12 is 1, 2, 3,
6, 8,
5, 6.
12. Okay, I got
6
12.
on the right. You got 12.
Yeah. I got 12, and I'll put that there. Just put it on a random motor. And then where's the ground?
Ground inside opposite of power, for example. Actually, the one after 12 is ground.
What's the number?
14.
14.
You have numbers over there?
No, but now that I know where 12 is, I know where all.
Oh, okay, good. Okay.
Okay, so I need to power the Pi from the battery, which means to go.
So excited to be like almost here. We're like, yeah, this is great. So what I want to be able to do is, in the same way we're ramping up and down, I would like to be able to pick an angle and have that angle just go around. So we actually watch it. We watch all four motors drive in the way that they need to satisfy the direction, the resulting direction of that angle, and then you just have it rotate like clockwise.
Yes, I know what you mean now. Because I was thinking too discrete before, I think was my problem.
Yeah, and my vision all along was like I want it to both spin and drive. I want to like use every little bit of these motors.
Okay, so that mounting is terrible.
Coolest thing.
That's okay. Let's put this somewhere off to the side. Just fold it away, I guess. Maybe I'll take it down, actually. I'm going to take it. This is the worst USB cable I could have possibly used.
Yeah.
That's my better one. Do you have...
No,
I would like a shorter one. You have a shorter one.
I don't know that I can find a few right now, but I will absolutely find one.
I think in your hackathon kit you had a few.
It's kind of a mess. Yeah. But next time I will have one. Does it need to be short right now?
It doesn't need to be shorter, but I definitely need a different cable.
Is that correct?
Yeah.
Alright, fine. I'll over it.
No, it's okay. I have another one somewhere, I think.
Oh, what the heck? I broke my pipe. Did we unplug something? Oh, yes, of course. Just plug the USB cable. Alright.
Plug the thing. That one. Yeah, plugging it into a battery because grounding is an issue. You know?
Yeah, not your kitty. Thanks very much. Yeah, we've come so far. Still a lot to do. I think the fun part is yet to start, though. Well, this is very fun, but I think it's gonna get really cool.
I think so too.
And then we can do some cool pathfinding, 3D sensing camera stuff. Did you find a cable?
Yes. All right. I wanted one with a shorter because the cable that I had the longest end to a USB
I see what you mean. Yeah, it's a very cheap one. I don't even know how I got this.
Like, see how long that
It's
is?
massive. Yeah. I don't understand.
This one's also pretty long, but not like that.
Well, yeah, we'll buy the best cable money can buy later. Okay, whatever you want, I got it. We'll make it happen for you.
This placement might actually be an issue because it comes too close.
Oh gosh. We'll fix it.
Oh, I'm just taping this.
This is great, man. This is awesome.
Oh, is the butt end of this pie falling off?
I pushed it down so that I could fit this. Right.
Oh.
I'll have to do some adjusting.
Alright. Can't it go over? If this thing is here, can't this one go over here?
Yeah, I'll have to rewire it, but that's okay.
Oh, because you shortened it?
Yeah, everything's like super.
Oh my god. You really want to make it tighter. Could have been a kids channel, but no.
Nope, not today. Sorry, kids.
Kids want to learn engineering too. Speaking of which, talk to people about your grand idea about educating people. Because Nacho Kitty mentioned earlier that she did not have a coding class in high school, and I think that was pretty instrumental in my life. Was my access to code earlier. I learned AppleScript initially at my home computer, and then I was able to go into class and did fairly well. And that helped me kind of jumpstart my confidence in software. So what are your thoughts from a hardware perspective? How to help kids?
Yeah, so I think there's this huge gap, and I really noticed it when I was in first or second year university when I was in a lab for a project-based class, and my project was completely hardware, not electrical. It was more mechanical. But there was a guy in my class that did a purely embedded project. So his project, he was capable of running a motor with an Arduino. He basically had an Arduino operating a relay, and the relay operated a motor contact, which is pretty cool. But it was so foreign to me. So I noticed at that point in time that there's a huge gap between what people think is possible and how to, like, people have this it's so foreign, and it's the same thing that you were saying earlier, the fact that it's so foreign to
everyone wants to see your face.
the fact that it's so foreign to people to figure out how electronics works. It's just this huge black box. But then you get a piece of technology like the Raspberry Pi, which has the most simple interface you could ever imagine when it comes to an electronics starter kit. You start with learning how to light an LED, and you end by learning how to operate two motors simultaneously, making what's called a zoetrope. And if you don't know what a zoetrope is, you should look it up. But Arduino has done a really good job of sort of bridging that gap of understanding of how to do embedded electronics. But I think that there's a step further that you can go, and that step is introducing the idea of solving more challenging projects and coming out with something that you can use at the end. So if you had an idea of, let's say, for example, building an RC boat, and you built this RC boat such that it had snap-built components and all of the electronics required, an instruction manual as well as the circuit diagrams and example code, but like a fully open-sourced system so that you can actually manipulate it in ways and have the opportunity to make the boat however you want the boat to operate. If you want it to go faster, if you want it to go slower, if you want to change the motor, if you want to change the sensors on the device. Hopefully the instruction manual would give you enough confidence that you can sort of branch out of the exact path that the instruction manual was giving you. So the idea would be do something so cool and so foreign that it gets you hype and makes you want to Google. And I think that's the overarching goal, is to make people want to Google when they don't know something, instead of just saying I don't know something.
Get to that why.
Get to the why.
And they can create.
If you ask the right questions, that's all you need to do. Just ask the right questions. And there's always people like me, people like Lavin, people like Nacho Kitty, that just want to talk about what they know. You know, there's always going to be somebody that's willing to give you the time of day, because realistically, sometimes we just want to be heard. Anyway,
Often.
Oh.
That's good. I really like it. I'm very excited. I think this is going to be the start of something awesome like that. Is we could break this down into a digestible course and hopefully make that version kid friendly, so that anyone can dive right in and learn what we do.
Yeah, now that we've solved a lot of the problems as far as selecting the components and integrating the components, it would be quite trivial to create a manual to build this if you were given these components, which is pretty cool.
Yeah, you even mentioned the other day about the connectivity between pieces, and that's something in my other projects that are hardware based I've been struggling with. Is I have this power source or I have this other sensor, and I want to connect it to my device. Like, what are the intermediate steps? So like there's hundreds of options just for connection pieces, and I think that's a big barrier to entry. That if we say these are the hardware you can get, and they all communicate together and standardize that for our particular projects, that's gonna be a lot easier to get people started and not have to worry about this nitty gritty details that are often not as important really.
Even if we went as far as building a website that had the components that we know are going to be used and most useful, but still giving the user the opportunity to find them, because that's a huge thing as well. Finding the components that you need, like building this car is great, but the hardest part, in my opinion, is buying the parts, pulling the trigger and saying, yes, I have everything we need. Now let's order this this large sum of components and for a huge sum of money. It's hard to pull that trigger and to give. That's still a learning process to be able to say I know everything, or at least 80% of the components that I need to get this project rolling. Now I can buy them. So maybe we even build a website that allows you to select the components that you need for a project, and then we kind of vet them, but still give you the opportunity to go through the process. We don't let people struggle to a point, because then you're having to commit, especially when you tell everyone you bought all this stuff. Yeah, that's a good point. Actually, on that topic, this is kind of unrelated, but on that topic, there's an interesting article I read one time about telling people when you're about to do a thing. Let's say, for example, you're trying to quit drinking or trying to go to the gym or trying to do something to better yourself. If you tell people before you start doing it that you're planning to start doing it, then you get the dopamine release of telling somebody before you've actually done the thing. So you've already got the happiness out of the event before you've done the event. And it actually makes it less likely that you do the thing, which is interesting. And it just kind of plays off your point of having to commit, because you've kind of told yourself that you've done it, I guess.
Yeah. We do have to just do a quick pause to restart our camera. And then we'll be back. Yeah, I think there's a memory leak in the streaming app. So yeah, we're going to restart that so that you can see the RC car again. So we'll be back in less than 60 seconds. Thanks, everyone.